guys, welcome to grade 5, lesson 4. So we have up to now been working with volume. Last week we talked about formulas for volume using area. So now we're going to kind of switch gears and we're going to start talking about multiplying multi-digit numbers. And one way that we can do that is by using what we call an area model. So we're going to be starting off on page 55. At the top, you'll see it says, you know how to multiply a 2-digit number by a 2-digit number. Now you will multiply greater multi-digit numbers. Use what you know to try to solve the problem below. So we're actually going to just step through the problem together, so you don't have to try and solve it on your own. The problem says a mall has a rectangular outdoor space that is 127 feet by 46 feet. So I'm going to start off by just drawing what we already know so far. We have a rectangular space. So I drew a rectangle. We know that one side is 127 feet. And we know that our other side is 46 feet. Now, as I read through the rest of the problem, it says there's a grassy section with a width of 40 feet and a cement sidewalk with a width of 6 feet. So I'm going to go ahead and say that we have one section that's 40 feet and one section that's 6 feet. So that would split my rectangle kind of like this. Oops. I have a 40-foot section on the top and a 6-foot section on the bottom, right? So this is my sidewalk section, this is my grassy section. Now it says, what is the area of the outdoor space in square feet? So we've divided our 46 feet into 40 feet and 6 feet. I'm going to do the same thing, 27 feet. I'm going to say that I have one area that is going to be 100 feet. A second area that is 20 feet. And because it's going to bother me that my last section is larger than my middle section, I'm going to adjust my rectangle. There we go. To show that I also have a smaller section that is 7 feet. So I have a 100-foot section for the 40-foot area as well as for the 6-foot area, a 20-foot section for 40 feet and 6 feet, and a 7-foot section for the 40 feet and the 6 feet. So I'm going to erase my original dimensions because really when we have 40 plus 6 we have 46, and when we have 100 plus 20 plus 7 I have 127. So I have just broken out these numbers, and you remember that when you break out numbers this way it's called writing it in expanded form. So I've written out 46 in expanded form and 100 in expanded form, and I've broken up my rectangle into those various quadrants as well, right? So now, I'm going to once again erase these, and now I'm just going to focus on my numbers. So first I have, this is my 100-foot section, and up here I'm going to multiply it by 40. Here's my 20-foot section that I'm then going to multiply by 40. Here's my 7-foot section that I'm also going to multiply by 40. Okay? We'll find the answers to those in a moment. First, I'm going to go down here and say now I have 100 still, but now I'm multiplying it just by this 6-foot sidewalk section. I have 20 times my 6-foot section and 7 times my 6-foot section. Now I can go ahead and solve each of these multiplication problems to see if we get what we call partial sums And then if I added my partial sums, I could figure out the area of my entire rectangle, right? So I would have 100 times 400. My strategy is I temporarily ignore the zeros. I had 2 zeros here and 1 zero here. I'm going to add those 3 zeros in at the end. But right now I'm just going to focus on 4 and 1. 4 times 1 or 1 times 4 is going to be 4. Adding in 1, 2, 3 zeros to make my answer 4,000. Same thing here. I'm going to temporarily ignore these zeros and just focus on the 2 tenths and the 4 tenths. I have 2 times 4 would be 8. Adding in 1 zero, adding in my second zero makes it 800. I have 7 times 40 over here. Again, I'm going to temporarily ignore the zero. I'm going to think of it. I don't really know my 7 facts as easily, but I do know 1 7 fact by heart, which is 7 times 3 is 21. So then I'm going to go ahead and think 4 is 1 more than 3, so I'm going to add 1 more group of 7 to 21. So I'm just going to count on 21 plus 7 more would make it 28. Plus 1 more, plus that 0 makes it 280. So I've done all of my partial sums for the top. Now I'm going to move to the bottom section. I have 106 times. That's like saying I have 600 or 600. I have 20 times 6 is like I have 26 times, or I have 12, and then that 0. And I have 7 times 6. Ugh, I don't like those 7s. But I do know that 6 times 6 is 36. So I'm going to add 1 more group of 6, which would make it 42. And now I have a product for each section of my rectangle. What I'm going to do now is I'm going to go ahead and add them all up. So I have 4,000. I have 800. I have 280. I have 600. I have 120. And I have 42. So if I look at these, I have 1, 2, 3, 4, 5, 6 numbers that I'm adding. I'm just going to double check. 1, 2, 3, 4, 5, 6. Yep, I got all of my partial products. And now I'm going to let. Before I move on, though, I also want to just point out that our area models relate to the product by size, right? So our biggest area is the 100 by 40 rectangle. That's our biggest rectangle, right? And it has an area of 4,000 square feet. My next biggest rectangle is 40 by 20. That's 800 square feet. I have this rectangle, which is 280 square feet, which is smaller than my first two. I have a long skinny section here, which is 600 square feet. A slightly smaller 120 square feet, and my itty bittiest part of my rectangle is 42 square feet. So my corresponding areas still compare with the size of that rectangle, right? Which makes sense because that's what we're measuring, is the area. So now I'm going to go ahead and come on over. I'm going to make sure this is my organizational strategy. I like to draw lines in between the place values to make sure that I'm adding up the ones in the right place value. So in my ones, I have 0 plus 0 plus 0 plus 0 plus 0 plus 2 would give me a whopping 2. In my tens, I have 0 plus 0 plus 8 plus 0 plus 2 plus 4. I'm going to go ahead and group 8 and 2 because I know that that makes 10 plus 4 more is going to make it 14 tens. So I have 4 tens and 10 more tens, or one group of 100 up here. Then I have 0 plus 8 plus 2 plus 6 plus 1 plus 1 more group up here. I know that 8 and 2 make 10, plus 6 more makes it 16, 17, 18, 8,000 and one group of 10,000. Now I have 4 10,000s plus 1 10,000 would be 5 10,000. So my total area would be, oh, I said 10,000. I meant thousands. My total area would be 5,842. So go ahead and turn to the next page on page 56. We're going to skip number 1 and go down to where it says number 2. It says, look ahead. When you multiply with multi-digit numbers, you need to pay special attention to place value. To help, you can use patterns in the numbers of zeros in the factors of a product and the number of zeros in the product. So remember, that's what I was doing over here when I said I temporarily ignored the zeros. And then I add in however many zeros I have in the factors. Here I have 1, 2 here, and 1 over here. I'm going to make sure that I have 3 zeros in my product. Now, for A, it says, look at the partial products used to find the product of 512 and 24. So now we're dealing with an entirely different problem. I'm going to go ahead and move my camera down here to some blank whiteboard space. Now we're looking at 512, and we're multiplying it by 24. So they're saying, instead of drawing out an area model, I'm just going to go ahead and look at the partial product. So first I'm looking at 4 ones and 2 ones. 4 times 2 would be 8. So I'm going to write out 8 right here because that is equal to 4 ones times 2 ones. Now I'm going to go ahead and still focus on my 4 ones. So now I'm going to multiply it by the 10, or the 110 that I have up here. So 4 times 1 would be 4, but it's not 1, it's 1/10. So 4 times 10 would be 40, right? 4 times 110, or 10. And lastly, I'm going to go ahead and still focus on the 4 here, and I'm going to multiply it by my 500 here. So I would have 4 times 5 would be like 20, but then I have 2 more zeros to make it hundreds. That's the result of 4 times 500. 4 times 5 would be 20, 1 0, 2 zeros to make it 2,000. So now I've dealt with my ones place for the number that for my second factor. Now I'm going to look at the tens place. So first I'm going to multiply my 2 tens by my 2 ones. So I would get 4 tens. 2 tens times 2 ones would be like 2 times 2, or 4, plus 1 more 0. Now I'm going to multiply my 2 tens times 1 10 that I have up here. 2 tens times 1 10 would give me 2 1 0 1 0, which would make it 200, which makes sense because we know that 10 tens would make 100. 2 tens 10 times would make it 200. I'm going to go ahead and lower my screen a little bit there. And then lastly, I'm also going to focus on my 2 tens times my 500, so 500. So 2 times 5 would give me 10. I have 1, 2, 3 zeros that I'm going to go ahead and add in there as my result of 2 tens times 500. So now I've dealt with both place values. I've found all of my partial products, and I'm going to add them up. So I have 8, 0, 0, 0, 0, 0 in my ones place. I have 4 in the tens place, 0, 4 in the tens place, 0, and 0. So I would have 8 in my tens place. In my hundreds place, I have 0, 2, and 0. So I have 2 in my hundreds place. And in my thousands place, I have, oh wait, yep, there it is. In my thousands place, I also have 2, but I also have 1 down here. So I would have 3,288. Wait a minute. Nope. Sorry. Just kidding. Because this is not 1,000, this is actually 10,000. So I have 2,000 here and 10,000 here, which is why it's so nice when you can line up your place values, which I didn't do. And so then I got confused with my answer. Okay, so let's try this again now. 8, still a bunch of zeros. 8. 4 and 4 and zeros would be 8. 0 and 2 and 0 is 2. 2 and 0 is 2. But now I have 1 in my 10,000 place. So I actually have 12,288 as my total answer for 512 times 24. So A says, look at the partial products used to find the product of 512 and each partial product to the number of zeros in the factor. So we did that. We said we have 40 is like 4 times 10. We have 1 0 here and 1 0 here. 4 times 500, I have 4 times 5 is 20. 1 0 here, 1 0 here. So we've already kind of done that as we went. B says, explain why the partial product 4 times 500 has 3 zeros, not just 2 zeros. So again, 4 times 5 is 20, but then we have our 2 additional zeros from the 100. Okay, we're going to go ahead and skip number 3. And we're also going to skip pages 57 and 58 and move right on to, actually, we're going to turn past page 59 as well because the problem is written at the top of page 60. So go ahead and turn all the way to page 60. Our problem says there are 128 pens in a full box. How many pens are in 35 boxes? So we have 128 in one box, but we want to see how many are in 35 boxes. So we would have 128 times 35, right? 128 in each box is 35 boxes. So first they've shown you as an area model. So I'm going to go ahead and again erase. I'm going to just start over. There we go. I'm going to start by drawing the rectangle. And the first part is I'm going to break it up. So it says to find the product 128 times 35, sketch a rectangle with dimensions 128 by 35. So we're going to say that this is 128. We're going to say that this is 35. But now I'm going to break those apart into expanded form and think of this as 30 plus 5, right? 3 tens and 5 ones. So to about there. So I'm going to split my height of my width of my rectangle in 2 parts, right? I'm not going to say in half because they're not equal parts, but I'm going to split them into 2 parts. One that measures 30 and the other that measures 5. Now down below, I'm going to go ahead and do the same thing, but I'm going to break my number apart into hundreds, which would be the biggest section. 2 tens. And just because it's going to drive me nuts if they're not proportionate. And 8 ones. So I have 100 plus 20 plus 8. And I'm going to go ahead. So now I still have 128 and I still have 35, but I'm going to temporarily erase those so I can focus on multiplying to find my partial product. So first I would have 30 times 100 in this box. I would have 30 now times 20 in this box. And 30 times 8 in my last box for the top part. Here I'm going to have 5 times 100, 5 times 20, and 5 times 8. So now if I were to go through and solve each of these, I'm going to think of 3 times 1 is 3, add in 1, 2, 3 zeros to make it 3,000. I have 30 times 20, 3 times 2 would be 6, 1 0, 2 zeros to be 600. 8 times 3, I know that 7 times 3 is 21, like I said before, so I'm going to add one more group of 3 to make it 24. add a 0 to make it 240. 5 times 100 would be 500, right? 2 zeros. 5 times 20 is 10 plus 1 more 0 makes it 100. And 5 times 8 is going to be 40. Now I could add all of them up. 3,000 plus 600 plus 240. In the first row is going to be 3,000. 6 plus 2 is 8, 4, and no 1. And then I could also add up my 500 plus 100 plus 40. I would have 640. Then I could add them up together. I would have 0 1s and 0 1s, 0 1s, 4 10s, 4 10s, 8 10s, 800, 600, 1,400, 3,000, 1,000, 4,000. So I would have, my product would be 4,480. There we go. Perfect. All right. The second model, it says to use the distributive property to find partial products and add them. Okay, distributive property, so remember our 3 properties of multiplication. We have commutative property, which says we can add them or we can multiply in any order and still get the same answer. Associative property, associates are people who group together, so we can group our numbers in any order we like and still get the same answer. Distributive property, we can also break up our numbers any way we like and still get the same answer. So multiplication is pretty cool in that we have those properties. So basically, that's saying that we're doing the same thing that we did over in our area model without drawing a big old rectangle for it. So we could say that we have 128, and I'm going to multiply 128 times 30, right, or the 3 10s. And I'm also going to multiply 128 times 5, because I have 5 ones. 30 plus 5 would get me 35. So I'm going to add my 2 products to go ahead and find my answer. So let's go ahead and do that. 128 times 30. I'm going to think of it as 8 times 30 is going to get me 240. Because 8 times 3 is 24 plus 1 more 0. 20 times 30 is going to get me 600. And 100 times 30 is going to get me 3,000. Then I'm going to come over here, 128 times 5. 5 times 8 is 40. 5 times 20 is going to be 100. 5 times 100 is 500. I'm going to add them up. So the 2 partial products that I get, I have 3,840 and 640. If I add those 2 together, no, let's go this way. If I add them together, we actually see that I already did that, but let's do it again just to double check our work. 3,840 plus 640. 0 and 0 still makes 0, 4 and 4 still makes 8, 8 and 6, I'm going to think of it as 6 and 6, which makes 12, plus 2 more makes it 14, 3 and 1 more makes it 4. So I have just verified by getting the same answer that my answer would be 4,480, but I've done it 2 different ways to make sure that my answer is correct. Okay, go ahead and turn the page. On page 61, Number 1 says, why is the area model divided into 6 sections? So remember at the beginning, we had, I'm going to erase this part for right now. We had 30 and 5 from 35. So we broke it into our place values, our 5 ones and our 3 tens. For our bottom side, we had 128. I had 1 in my hundreds, 2 in my tens, 8 in my ones. So I broke that number into 3 parts, right? So I now have a rectangle that has 2 parts by 3 parts. We know that 2 and 3 make 6. So we have our 6 sections because we've broken it up by the place value, 2 place values and 3 place values. Number 2, how do the 3 partial products in each multiplication equation in the second modellet relate to the 3 sections in each of the in each row of the area model? So I'm going to go ahead and bring it back down here. Instead of breaking up 128 and multiplying it by 30, we just did 138 times 30. So I have 1, 2, 3. We had, back this up a little bit, see both. There we go. So I had 240. I still have 240 over here. I have 600, 600, and 3,000, 3,000. Because that's like saying 30 times 100, 20, and 8, right? So I still got my same partial product. 128 times 5, same thing. I have 500 down here, 140. So I'm just breaking up my number into 2 different ways. Number 3, use the partial products 3,840 and 640 to find the product 128 times 35. How many tens are in the 35 full boxes? We did that both ways. We found that we had 4,480 tens in the 35 boxes. We're going to skip numbers 4, 5, and 6 just for the sake of time because this is kind of a longer lesson. I would like for you to go ahead and do turn to page 62 and do problems 7, 8, and 9 on your own. So pause the video, do 7, 8, and 9, and then come on back to check your answers at the end. You're already done with the problem? I didn't even have time to erase the board. Okay, let's go ahead and double check your answers. So number 7 says find the product 120 times 25 times 40. Does it matter what order you multiply the numbers? So remember, order doesn't matter when we multiply. That's that commutative property. So we can do them in any order, but we're going to multiply 120 by 25 by 40. So you might choose to get this big number out of the way first, right? And say that you have 120 times 25. And then whatever your answer is here, you multiply it by 40. You could also say, I'm going to tackle my smaller numbers first and say 25 times 40 and then multiply those by 120. But I'm going to do it the first way. I'm going to go ahead and start with 120 multiplied by 25. So first, I'm going to think about what 5 1s times 0 1s would be. Well, any number times 0 is going to be 0. Now I have 5 1s times 2 10s. So that would be like saying, I'm going to go ahead and think about it as 5 times 20. 5 times 2 would be 10. Add one more 0 to it to make 100. Now I have 5 1s times 100. That would be 500, right? That's what I'm going to think about is 5 times 100. So right now I have all of my partial products for the 1s place. Now I'm going to switch over to the 10s place. I have 2 10s times 0. Again, that's going to be 0. Let's just go ahead and clarify that. Now I'm going to go ahead and move over to the 10s place. I have 2 10s times 2 10s, so that's like 20 times 20. I'm going to just focus on my 10s place. 2 times 2 would be 4. Adding in 1 2 zeros. And then I have 2 10 or 20 times 100. 2 times 1 is going to be 2. I have 1, 2, 3 zeros, making it 2,000. Now I'm going to add up all of my partial products, paying a special attention to place value so I don't get them mixed up. So first I'm going to go ahead, and again, I find it helpful to draw in lines so that you're lining up your place value. So I have 0 plus 0 plus 0 plus 0 plus 0 plus 0 is, of course, 0. In my tens place, I also have 0 plus 0 plus 0 plus 0, another 0. In my hundreds place, I have 100 plus 500 plus 400. I'm going to combine the 4 and the 1 to make another 5. 5 and 5 makes 10, so that would be like 0 hundreds and 1 more thousand. I have 2,000 plus 1 more thousand would make it 3,000. So 120 times 25, that's just this first part, is going to equal 3,000. So now I'm going to slide over here. Now that I know that 120 and 25 is 3,000, I can multiply that by 40. Now I could go through and find my partial products each time, but I'm going to go ahead and work smarter, not harder, and I'm going to temporarily erase my zeros, and then I'm going to add them back in at the end. So I have 3 times 4, I know that makes 12. I had 1, 2, 3 zeros up at the top, and 1 more 0 here. So I'm going to have 1, 2, 3, 4 zeros in my total answer, which would be 120,000. So the answer to number 7 is 120,000. Okay, now let's go ahead and focus on number 8. This math lesson is giving me a full body workout. I'm having to use my entire board and erase it multiple times. My workout for the day. All right, number 8 says find the volume of the rectangular prism. How is this problem similar to problem 7? So we have a rectangular prism that has a length of 120 centimeters, a height of 40 centimeters, and a depth of 25 centimeters. Okay? So remember, to find volume, we're going to multiply length times width times height. So here, I have my length is 120, my width is 40, and my height, actually my height would be 40. But again, order doesn't matter when we multiply. So how is this related to problem 1? Well, we're multiplying the same numbers, right? We're multiplying 120 times 25 times 40. So you have already found that the answer is 120,000. But now because we're talking about volume, we want to make sure to include our units. So it's 120,000 cubic centimeters. So if you did not include the label, please plug that in now, because that's the important distinction between number 7 and number 8. Okay, number 9. A library bookshelf holds 156 books. There are 15 bookshelves in a certain section of the library. How many books can the library place on these bookshelves? Show your work. Okay, so I've already written it out, but again, this is a word problem, so go through your strategies, circle the numbers, underline the problem, and box in keywords. So the numbers you should circle, 156 and 15. The question is, how many books can the library place on these bookshelves? And the key word there being these bookshelves. So we're just focusing on the 15 bookshelves. How many books fit on those 15 bookshelves? So again, I can go ahead, I'm going to think of this as 10 and 5. That's that distributive property. So I'm going to multiply 156 times 10. And 156 times 5. And then I'm going to add my two products together at the end. So first, any number times 10 is like adding a 0 to the end. So 156 times 10 is going to be 1,560. 156, I'm going to have to work a little bit harder on this one. 5 times 6 is going to be 30. 5 times 5 tens, or 50, is going to be 25, but add a 0 for that 50, make it 250. And 5 times 100 is 500. If I add my partial product, I get 780. So now I'm going to add my 1560 to my 780. 1,560 plus 780. 0 and 0 make 0. 6 and 6 would make 12. 8 is 2 more than 6, so 2 more than 12 would be 14. 7 and 5 would be like 5 and 2 more. 5 and 5 is 10 plus 2 more is 12. 11. 1 and 1 makes 2. So my answer would be 2. Nope. Where did I go wrong? 1560, 780. I said, oh, 12. One more than that would make it 13. There we go. 2,340 would be the answer for that one. So 2,340 books would fit on just those 15 bookshelves. All right, if you turn to the next two pages, 63 and 64, these pages are what we're going to cover in our practice work on Thursday when we meet. So go ahead and keep on turning past page 65 all the way to page 66. So the problem at the top of page 66 says find the product, find the answer to the multiplication problem, 1,429 times 42. Okay, so we're going to multiply these two numbers. So the first model, it says you can use partial products. So first we're going to think of 2 times 9 is 18. 2 times 20 is like 40. 2 times 400 is 800. And 2 times 1,000, it's like saying I have 1,000 two times, I have 2,000. Now I'm going to keep going, but I'm going to switch to a blue pen, partly because my black pen is dying, but also partly because I want to show that we're going to be now multiplying the 10. So 4 tens times 9 ones, so 40 times 9. 9 times 4, I know is going to be 36. Add a 0 to it to become 360. 40 times 2 tens, or 20. I'm going to ignore my zeros and say 4 times 2 is 8. Add in 1, 2 zeros to make it 800. Back it up. There we go. Now I have 4 tens times 400. 40 times 400 Again, I'm going to ignore my zeros and just focus on 4 and 4 is 16. Add in 1, 2, 3 zeros. And lastly, 4 and times 1,000 is like saying it has 1,040 times or 40,000. Okay, so now I'm going to go ahead and add all of these up to find my answer, right? I'm not going to do that yet, but that's how I would found all of my partial products, and then I would add them all together to find the solution. But before we do that, let's go ahead and look at the second modelet, which says you can also use the standard algorithm. So remember, an algorithm is just a way, steps that you can use each time to solve a problem. So I'm going to show you what that looks like. It's the same process that I just did with partial product, but I'm going to save a little bit more space writing it out. Now, the thing with algorithms, just like when you're adding multi-digit numbers, is it's really important to stay organized. So I'm going to make sure that my place values are lined up, which they are. And then I'm going to go through and I'm going to first of all think about, I have 2 times 9 is going to be 18 still, right? So just like when we're doing addition, I'm going to have 8 in the one place, but I have one more group of 10. So I now have 2 times 2 tens plus one more 10. I can think of that as 2 times 3 tens, which is going to give me, I just want to make sure I'm doing, no, 2 times 2 is 4 plus one more is going to make it 5. 2 times 2 tens, yeah, is 4 plus one more makes it 5. So I'm not adding these two together. I'm not saying 2 and 1 makes 3 and multiplying that by 2 because then I would get 6, right? I'm saying I have 2 times 2 is 4 and then one more 10 from over here. So I'm adding that one more 10 to the 2 tens times the 2 1s. Now I have 2 1s times 400. I know that that makes 8 in the hundredths place. And then 2 times 1,000 makes it 2,000. So now I've dealt with my 1 place. Now I'm going to go ahead and go to my 10 place. So because I'm dealing with tens, I'm going to put a place marker in there saying that now I have 40 times 9 is going to be 360, right? But I'm going to put my 6 in, and my 3 is now going to go up above my 2. So I'm all done with this one. Now I'm thinking of it with a 2. So I have 4 tens times 2 tens. I know that that would be 800 plus I have 8, 9, 10, 11. So I would have 100 and one more 100 up here. 4 tens times 400 is 16 plus one more makes it 17. But I'm going to bring one more up here. 4 tens times 1,000 is 4,000 plus one more 1,000 makes it 5,000. Now when I add them together, I have 8 plus 0, 5 and 6, 8 and 1, and one more. Oops. 7 and 2, and one more. And 5 and one more. Okay, so let's just go ahead and take a step back real quick before we get to solving that problem. I just want to go back to why I'm adding the numbers up to the top. So remember, we're thinking of it as not 2 times 9, we are thinking of it as 2 times 9, which would get us 18. So I have my 8 ones, right? But then I have one more in the tens that I'm going to add in later. So that's like thinking of it as 18 added to 2 times 2, which would be 4, but 2 tens would be 40. So when I added it up here, remember, I just wrote it in as a 5, but that was like saying that I had 18 plus 40, which would make 58. Then I'm going to go ahead and do the same thing. 2 times 4 is 8, and 2 times 1 is 2. So far, so good. Now I have 4 10 times 9. That would give me 360. But I also have 4 10 times, or I'm sorry, 4 10 times 2 tens, which would get me 8 tens, or right, or 8. 4 10 times 2 tens, I have 2 more zeros, so I would get 800. So I'm adding my 8 and my 3 to make it, 8 times 2 is 10, so I would have 11. And then I have 4 times my 400. Oh, I already did that. That was the 800. See, even I get confused with this. Yeah, so far so good. And then 4 times my 4,000 is, so, wait, 4, okay, 410 times 9 is going to get me 360, right? So I'm going to go ahead and leave my 6 in my 10s place, erase my 300, and then I'm adding that to my next group. So I have 10 times 400 now is going to be like 8, but I have 9, 10, or I'm sorry, 16, but I'm adding 7, 8, 9. Why is this not adding up? 4 times 4 is 16. Bear with me, guys. See, this is hard stuff. Okay, one more time. 4 times 9, still 360. 4 tens times 2 tens is going to get me 8 tens, or 800, because I have a 0 here and a 0 here. 4 tens times 400, I get 16, but I get 1 from the 10 here and 2 tens here. 4 times 1,000 is 4. Nope. 40 times 1,000 is 40,000. So now, if I were to add these up, I would still have my 0 and my 6, because I'm not adding anything more to those. But here I have 3 and 8, 8, 9, 10, 11. 11. I have 6 and 1 more, which would make it 7. And 4 and 1 more makes it 5. When I add them up, I have 8, 5 and 6 makes it 11. 8 and 1 plus 1 more make it 10. 7, 8, 9, 10. And add 1 more to my 5. I didn't line them up very well. 5 and 1 more would make it 6. So I still get my same answer of 60,018, but I took up way less space. Now, you can see that even somebody my age still struggles with keeping your products organized with this. So the algorithm is a little bit simpler in that you're not doing as much writing, but it is harder to keep track of everything. So go ahead and turn to page 67, number 1, which is why we teach you guys multiple strategies, because then you can use the strategy that works best for you. I know the algorithm and I can do the algorithm, But to double check my work, I'm still going to be using those partial products as a way to double check my work. Okay, so turn to page 67. Number 1 says, where do you see multiplying by ones and tens in the first modelet? Okay, so your partial products, you have 18, 40, 800, and 2,000, showing multiplying 1,429 by 2 ones. So again, our problem is 1,429, and multiply it by 2. So we got our partial product of, once again, 18, 40, 800, and 2,000, right? When we added those together, we got 2,858. For our tens, we multiplied 4 times 9 to get 360, 4 times 2, I'm sorry, 4 tens times 9 to get 360, 4 tens times 2 tens, or 40 times 20 to get 800, 4 tens times 400 to get 1,600, and 4 tens times 1,000 to get 4 tens, yeah, times 1,000 to get 40,000, which when we added those together got us 57,160. Excuse me, my goodness. More coffee is in order. So to get those partial products, we're multiplying the one place by each place value of our 1,429. And then we're also doing it for our tens, our 4 tens, so 40 times 1,429. So we got 2 partial products in both ways that we solved it, right? So we have combined our partial products to add them together, and this is what we got. Number 2 says, look at the second modelet. How do the partial products 18, 40, 800, and 2,000 relate to the first step? Well, when we added them, that's what we got. Number 3, look at the second modelet. How do the partial products 360, 800, and 1,600 and 16,000 and 40,000 relate to the second step? When we added them, we got 57,160. And so our total answer, number 4, says complete the multiplication in each modelet by adding the partial products. So we did it with our more expanded form, and we also did it with our standard algorithm. In both cases, we got 60,018 as our answer. Number 5 says compare the partial products model and the standard algorithm model. So again, we got the same answer. We basically did the same steps, but the algorithm kind of squishes that information together. Now, some pros to that, you save a lot more whiteboard or paper space. The cons to that is, as you can see, even I'm getting confused by doing it. So it's really important to stay organized with it. And you can even combine the two, right? So I did a partial product model after I found the first partial product. So go ahead and turn to page 68. You've got numbers 7, 8, and 9 to do on your own, and then we'll go back and review together. Okay, now that you've completed numbers 7, 8, and 9, you pause the video, right, so that you can do those? Okay, go back and pause the video so that you can finish those up. Okay, now that you've finished numbers 7, 8, and 9, let's go ahead and review. Number 7 says the base of a storage bin has an area of 504 square inches. So the base of a storage bin, this is our storage bin, and we're going to say that the base, the square base, has an area of 504 square inches. Okay, so that's the length times the width. Its height is 18 inches. So we're going to take 504 and multiply it by 18. Right? What is the volume of the storage bin? So our volume is going to be 504 times 18. It says estimate to check for reasonableness. So I'm going to start by moving my problem up. 504 times 18 is what we're dealing with. Now again, you can go ahead and solve this any way that works for you. If you want to continue to work with partial products, go for it. If you want to work on the standard algorithm, that's what I'm going to be showing here, hopefully a little bit more clearly than the first time. So first I'm going to go ahead and think about my 8 1s times 4 1s. I know that 8 times 4 is going to get me 20. Nope. Yep. 7 times 1. I always get confused with the 8. So 7 times 1 is, 7 times 3 is 21 plus 3 more to make it 8 3s would be 24. So I was right. Okay, that's good to know. So I would have 24. So I'm going to write a 4 here and a 2 that I'm going to add after I multiply my next 2 digits. So I have 8 1 times 0 10. Any number times 0 is going to be 0, but I'm adding on 2 more. So I'm going to make it 2. And then 8 times 5 is going to be 40. Now I'm going to switch over to my tens place. I'm going to draw a 0 to make sure that I'm saying that I'm working with 10. So 10 times 4 is 40, right? So I'm going to write in 4, and I already have my 0. 1 times 0 is 0, so I'm going to write in a 0 here because I have 10, 10. 1 10 times 0 10. I would be talking about 0 100. 1 10 times 500. 5 times 1 is going to be 6. Nope, that's the addition teacher does. 5 times 1 is 5. Now I'm going to add my 2 products together. I have 4 and 0 is 4. 2 and 4 make, okay, 0 and 0 makes 0, and 4 and 5 makes 9. So your box, why is that not working out correctly? Oh, because did I, 8 times 4 is 32. Okay, let's start over, shall we? 3 times 4, not 24. Nope, 32. You guys knew that already. I'm going to go ahead and write in 2 here and 3 up here. 8 times 0 is still 0, but now I'm adding in 3. So it's like I'm saying 8 times 4 1s and no 10s, right? So 8 times 4 is 32. There's my 32. 8 times 5 is now going to be 40 still, so I'm going to write in 40. So I would have 4,032. Okay, now let's think about our 10. 10 times 4 would be 40, right? 1 times 0 is going to be 0. 1 times 5 is going to be 5. So it's like 10 times 500 would be 5,000. So my 5 is in my thousands place. Well, when I add them up, I get 2, 7, 0, and 9. So our answer really should be 9,072. But we're not done yet because we're talking about volume. We're talking about inches in this problem, so I'm going to say cubic inches. So 9,072 cubic inches. But wait, we're not done yet because it did say to estimate your answer for reasonableness. So I'm just going to go ahead and estimate that my 504 is pretty close to 500. My 18 is pretty close to 20. So I'm going to go ahead and multiply 500 times 20 to estimate my answer to see if my answer that I actually got is reasonable. I would have definitely gotten this from the first time around. If I had continued with my wrong answer, I would know it by now for sure, except that I already caught my error. So now I'm going to go ahead and use my strategy of just looking at my digits and then adding in the 3 zeros after. So 5 times 2 is going to be 10. Plus 1, 2, 3, 0. So I would get 10,000 as my estimated answer is 9,000, fairly close to 10,000. Yeah, it's not exactly close, but because we're estimating, we know that our answer is at least reasonable. All right, let's move on, shall we? Can we, please? All right, number 8. A school supply store has boxes of markers with 25 markers in each box. There are 1,075 boxes of markers in stock, because of course there are. How many markers does the store have in stock? So you have boxes of markers with 25 markers in each box and 1,075 boxes. So 1,075 boxes, 25 box markers in each box. So we have 25, 1,075 times. So again, I'm going to use the standard algorithm to go ahead and solve this problem. So I'm going to start with 5 times 5 is going to be 25. I'm going to put my 5 here and add another 2 after I'm done multiplying my 7 and 5. 7 times 5 is 35, 36, 37. I just want to make sure that I'm doing this right. Okay, there we go. 5 times 0 is 0, plus 3 would make it 3, and 5 times 1 is 5. So the first part, just multiplying my 5 ones times 1,000. So I'm thinking of this. Here's my think bubble. As 1,075 times 5. Okay, so I'm taking care of that. Now I'm going to focus on 1,075 times the 20, which is just like that area model in that I'm breaking apart my numbers. We also call it the distributive property. So my think bubble is out. So now I'm going to multiply my 2 10s or 20 times 5. That's going to be 100. I'm going to have my 2 10 times my 700. So I'm probably going to have to change this. I'm going to put my 1 up here to remind me that I'm dealing with one more. I want to make sure that I'm doing this right because now I'm feeling a little gun shy. All right. So 20 times 7. 20 times 70, so I'm going to think of it as 2 times 7 is 14 plus 1 more would make it 15. Bring 1 up there. 2 times 0 is 0 plus 1 is going to make it just 1. Okay, so far it looks good. And 2 times 1 is 2. So now I'm going to add them up. 5 and 0, 7 and 0, 3 and 5, 5 and 1, and 2. For a total answer of 26,875 markers that they have in stock. Okay, number 9. What is the product 257 times 34? 237. We're multiplying it by 34. So again, I'm going to write out the standard algorithm. I have 4 times 7 is going to be, give me a second, 4 times 3, or 7 times 3 is 21 plus 7 more would make it 28. My 8 down here, and 2 up here. 4 times 3 is 12 plus 2 more makes it 14. 4 times 2 is 8 plus 1 more makes it 9. So my first product that I'm answering, no, why is that not looking right? It's very frustrating. Let's start over. 4 times 7, yes, that is 28. 4 times 3 is 12. Oh, that's why, because I wrote, there we go. Okay, let's try this again, shall we? 4 times 7 is still 28, but now I have 4 times 5, which would be 20, plus 2 more makes it 22. Great. 4 times 2 is, nope, yep, 4 times 2 is going to be 8, plus 2 more makes it 10. Hallelujah, the teacher's edition says that I'm right. Okay, now I'm going to look at my 3 10s. 30 times 7 is going to be 21. Nope, I did that wrong. Because it's not 21, it's 30 times 7, so I would have a 0. 21. 3 times 5 is 15, 16, 7. 3 times 2 is 6, plus 1 more makes it 7. Heck yeah, on the right track finally. 8 and 0 is 8. 2 and 1 is 3. 0 and 7 is 7. 1 and 7 is 8. Your total answer should be 8,738. Pages 69 and 70 are going to be covered on our Thursday meet. So bring those pages. Pages 71, 72, 73, and 74 are going to be, I don't know about you, but even just getting through this lesson kind of made my brain hurt. I hope you enjoyed watching your teacher struggle. And I'm sure you did. That's not even a question, right? I know you enjoy watching your teacher struggle. I hope that it did end up making sense in the end. Remember that even if the standard algorithm doesn't make sense, you can still use different ways to solve this problem. So this is why we teach different ways so that you can double check your answers. So even if you don't have a teacher's edition that shows you the answers, you can still use estimating to see if your answer is reasonable. You can use partial products as a way to check your answer. You can use an area model as well to help check your answer as well. All right, I will see you guys on Thursday for those practice pages. Have a great rest of your day. I'll see you next time. Bye.